Welcome to the session number 16 from the playlist of electromagnetic induction. The topic is finding the direction of induced current using the Lenz law. And this session is in continuation of the session number 15 in which we have studied about the Lenz law. So here I have written two important points. The first point says that as per the Lenz law, the direction of the induced current is such that it opposes the change in the magnetic flux that produces it. Or in other words, we can say that the induced current will create a magnetic field which opposes the initial changing magnetic field. Now, in order to understand this, point number one, I have drawn here one simple diagram in which there is a current carrying wire. This is the current carrying wire. This is the current carrying wire in which a current I is flowing in the direction as indicated by this arrow, and I have considered this current to be increasing with time. Now, the direction of the magnetic field which will be produced by this current carrying wire will be given by the right hand thumb rule, and as per the right hand thumb rule, the thumb points towards the direction of the current and the curled fingers will give us the direction of the magnetic field. So if I put the thumb here, so the direction of my curled fingers will give the direction of the magnetic field. So in this case, the direction of the magnetic field is into the plane of the paper, and this is the coil here which is placed adjacent to this wire. So here these cross marks indicate that the direction of the magnetic field is directed into the plane of the paper. Now here the current is increasing with time. It means that the magnetic field due to this current carrying wire will also increase with time, and due to the change in the magnetic field, there will be a change in the magnetic flux, and because of the change in the magnetic flux, there will be an EMF induced in this coil which is placed adjacent to this current carrying wire, and because of that induced EMF, an induced current will be produced in the coil. Now the direction of the induced current will be given by the Lenz law. That is, the direction of the induced current will be such that it will oppose the change in the magnetic flux that produces it. So here the direction of the magnetic field because of this current carrying wire is directed into the plane of the paper. That is, it is directed inwards. Therefore, the direction of the magnetic field due to this induced current will be directed away from the plane of the paper, or it will be directed outward. Now in the case, we know that in the case of a circular coil, if the current is flowing in the anti-clockwise direction, as indicated by this arrow, then the direction of the magnetic field is outward, or you can say away from the plane of the paper. So here, since the induced current will oppose the change in the magnetic flux due to this current carrying wire, therefore the direction of the induced current will be anti-clockwise, because if the direction of the this induced current is anti-clockwise, then the direction of the magnetic field because of this induced current will be directed outward, or you can say away from the plane of the plane of the paper. So in this way, it will be able to oppose the change in the magnetic flux. So in this case, the direction of the induced current will be anti-clockwise. So this is how we find the direction of the induced current by using the Lenz law. So in the next session now, I will be coming up with a couple of questions based on the topic of Lenz law. So till then, have a nice day. Bye.